Okay, welcome everybody. This is the setup for the Coriolis lab. So you'll see you have an H and an L to represent your pressures. You've got a pie plate here, and you've got a piece of paper. We're going to use the piece of paper just to draw on, and the pie plate's going to represent our rotating Earth. So because I'm going to draw on the piece of paper, when I tape this, I kind of want to stay out of the way, so I'm just going to tape it around the edges. You can go however you want, but just keep that tape out of the way of your drawing surface. And our colored pencils are going to represent wind or any other object that's on that rotating surface. So our first part says, what happens when we draw a straight line and the pie plate's not moving? So if we have a non-rotating Earth, wind always blows from, hopefully you said high to low. So if I have a non-rotating surface, my wind is going to always blow from high to low. And so I know I can draw a straight line. You might try a couple of those because you might notice that there's like those rivets in there. So what happens if I happen to encounter a rivet when I draw my line? My line is not perfectly straight, but you can see how it gives a little wobble, but overall the general shape is straight. It'll help me kind of keep in mind when I'm doing my trials whether or not something else is influencing my data. So that's my control for the bottom of page 1. Then if you look on pages 2 and 3, you have a spot to do some experiments. We've given you space for 6 experiments. That's the minimum. If you'd like to do more, you can. You'll just have to maybe make your observations on the square instead of in your notes. For each experiment, you need to identify your variable. Your variable could be spin speed. It could be spin direction. It could be how fast you're moving your wind or your pencil. It could be how hard you're pressing, in other words, the friction across the surface of the Earth. It pretty much whatever you'd like. You'll notice there are spots for several different trials. Again, good science says we should do more than one trial just to make sure what we did was not a fluke, that we get the same result every time. So in today's experiments, it's up to you to always draw from high to low. The other thing to keep in mind as we draw our wind arrows, I want to make sure that I'm always going from that H to that L. The other piece I want to make sure that I'm doing is I'm using both sides of my paper to conserve resources, but I also want to make sure I label the head of the arrow as well as the tail of the arrow. That way I can identify what direction my arrow is curving. So let's say I want to spin my pie plate counterclockwise, and I'm going to make a wind arrow. And as I spin my pie plate counterclockwise, I'm going to start at my H and go to my L. So I'm just going to put my pencil down there. And I know I ended right there, so I stop right away, and I just draw that darker so you guys can see it. And I make the head of my arrow right away. Because if I looked at this line, and what I notice here is that as I go up here, it curves to the right. But if I were to have drawn the head of the arrow on this side, that arrow now looks like it curves to the left. And so what you need to be careful is you know where you started and where you stopped. Another way to do that is to put an actual dot on your paper to start, so that way when that dot comes by and I go from high to low, I know I have to start at that dot, and I finished away from that dot. Doesn't matter that I didn't quite hit the dot, so you see my arrow started right there, and my arrow went like that. And now I can see, hey, that arrow curves to the right. And so, again, my first trial curved to the right. My second trial, it curved to the right. Maybe on my third trial, I will get the same result. Maybe I won't. That's why we're going to do 3 trials. So it's your job today to identify your variables, identify your constants, make sure you do multiple trials for all 6 experiments.